Hello students, welcome back to this lecture of part 2 and we're going to learn about rotational dynamics. Okay? The last class we learned about moment of inertia basic for a point mass. Do not get confused, do not say for any mass, it is only for point mass. So that is basically for basics of moment of inertia. Now, I said there are many types of moment of inertia we can find. Okay. Now, I'll give you an example. Okay. Now, moment of inertia for a rectangle. Okay, for a rectangle. Okay. So this is the center of the rectangle. Am I right? Yes. So this is L. The length is L, and the breadth is B. Now I will take a small portion from the rectangle. I'll take a small portion of a rectangle and I'll eat it so nobody sees what I'm doing. I'll eat it and I'll say that, and so nobody thinks that I ate a piece from here. The length of the piece which I ate was dx. The length of the piece was dx and the mass of the piece was dm. Now from the center of the item to the amount which I eaten, the distance is x. So now I want to know the axis line is like this. So now I want to find like this axis for I1 like this, for I2, and then from the z axis. Now this is I1. Okay, I'll explain you. And from the center rectangle z axis I3 now I want to find. Can I find I1, I2 and I3? Yes, surely I can find. Yeah. Now, how to find this? Okay, so I will explain you in a way that you can understand. So now, this is a rectangle. This is a what? This is a rectangle. Okay. So now this is a rectangle means now I want to put it along this axis. That means it will rotate like this. Now this axis like this. That means it will rotate like this. Now this axis. That means it will rotate like this. Okay. That was a flop. So it will rotate like this. Okay, understand, it will rotate like this. Now, okay. So how can I tell I1, I2 and I3 value? Okay. So now I'll reuse this mark only. I1 I want to find, I2 I want to find, and I3 I want to find. So first I'll find I1. Now the mass of this strip is dm. So that means I will write sigma. What is sigma? It is areal density. That means it has mass by area instead of mass by volume or mass by length. It has mass by area instead of mass by volume or mass by length. Okay. So that means mass of the total is m. Take it as capital M, and the area of this is L into B. So this is a density. Areal density. Now dm is equal to sigma dA based on any part on the thing. dm is equal to sigma dA. That means dm value I want to find. So it will be sigma is m by L. dA is the area of this small strip. So the mass, okay, so the length of the area. The strip is like this. dx is the length. Length, and b is the breadth. B is the breadth. Okay. Now it will be dx into b. So b will cancel. dm is equal to m by L into dx. dm by L into dx. Now I is equal to dm1. Now the length from the center, perpendicular distance from the axis of rotation I told. So this is perpendicular distance. Okay. So now this is one rectangle you have given. center and the length of the small this one here. So the length I told it is x. The length I told it is x because mr square I is equal to dm into mr square. So this is not a point mass, but I'm just telling because this is negligible mass I can take. I can take this as negligible mass. So negligible mass means point mass only, no? Yes. Okay. So now the distance from the center is x. So x square. That means I is equal to m by L dx into x square. Now I will di1 dm into x square. Now integration on both sides I will take. So I1 is equal to m by L. Now what limits can I take for integration? Plus L by 2 minus L by 2 I will take. Because that is the only two limits we can take whenever we are dealing with a rectangle. When we are dealing with a rectangle, that is when it is here, that means we have to take plus L by 2 and minus L by 2 as the two limits. Okay, so that means I1 is equal to m by L into x cube by 3 L by 2 minus L by 2. So I think you know integration. So m by L into x cube, which is L cube by 8 plus L cube by 8 minus plus. So m is equal to, sorry, 24 will come here because here by 3 is also there. So 24. So m by L into, so here you will get L cube by 12. So L cube will cancel to get L square. So m L square by 12 is the first inertia. So I hope you understood this part, how we got it. Now same way you do for I2. Instead of taking like this, take it like this one, mass dm dy, anything you will take, you will get, I will guarantee you will get mb square by 12 I2 value. Now for I3, by using one axis called perpendicular axis theorem, I will explain that. So ml square by 12 plus mb square by 12, which will get I3 as m L square plus b square by 12. So these are all very important things we have to know. Rectangle is the most important one we have to know. Rectangle, ring, disc, sphere, all of these are very important to know. Cylinder also sometimes it is important. Triangle and rectangle is rectangle is mostly common, but triangle is very rare. Okay, so I will give you some value. Now this is, so I1 is what? ml square by 12, I2 is what? mb square by 12, and I3 is ml square plus b square by 12. So I hope you understood this. So I'll erase this now. Now, I'll give you very important things. For now, I'll give you first for a ring. For a ring, now I1 means, now for ring there will be three diagrams. Okay, so now ring, this is, now mass is like this. This is I1. Now like this ring, okay, read the question properly, ring. Because many people will think it as disc and they'll substitute disc moment. Okay, so now this is along y-axis, along x-axis and along the z-axis. Okay, so along the y-axis, along y-axis, along the x-axis and the z-axis. Now what will be the moment of inertia for this will be half mr square. For this will be half mr square. So this will be mr square. Now you saw this? Yeah. Next one, for it's a disc. For a disc. For disc, now this is a disc. Okay, I'll shade in like this to tell it is a disc. along y-axis, x-axis, and z-axis. So now, so this moment of inertia will be 1 by 4 mr square, 1 by 4 mr square, and mr square, half mr square. Okay, so this is the value for all three moment of inertias for ring and disk. Because sometimes they will ask questions based on this also. Many books they only give z-axis, only z-axis, only x-axis, or only y-axis they'll give. But I am giving all three. So please note it, though, very very important. Okay, so next, after this, what object is a solid cylinder. Now next is cylinder. Okay, cylinder. Cylinder. Now cylinder for cylinder one which will be like this. Now first will be on y-axis. Next will be on x-axis. And last will be on z-axis. Now you are asking, Arnav, both of these are y and z are say? I will explain. So now this is a cylinder. I know I took a Pringles can. Okay, this is a cylinder. Okay, now for this cylinder, y-axis rotation is like this. Okay, wait. Y-axis rotation and z-axis rotation both are same. Sorry, you are right. Okay, I didn't read this. I didn't see it properly. I'm sorry. I'm very sorry. Okay, that means for y it will be what? mr square, because see now if I extend a disk, this is a disk, and if I extend, if I do it like this, means I'll get cylinder. So that means it will be the same moment of inertia. This also will be same moment of inertia. But now this one, if now horizontally I will examine it. I'll give you tricks to remember. Okay. Now this looks like a rod. Plus there is a small disc also inside. It looks like, so I'll put disc. Okay, correct, no? Okay, now for disk, if it's on like this, now this is talking about this case. That means it will be 1 by 4 mr square plus rod in moment of inertia is always ml square by 12. So the moment of inertia of all this will be ml square by 12 plus 1 by 4 mr square. This is for cylinder. Please note this 3 down. Please note it down. Okay, wait. I will shade this inside. I'll tell you why. Because we are going to study hollow cylinder. So that means when there is a small, when there is part of the cylinder not there. So please note this down. Yes. Okay. So now, okay, if you want for rectangle again, I'll give you rectangle again. So rectangle means this is for y-axis, x-axis and z-axis. So this will be ml square by 12, mb square by 12 and m into l square plus b square by 12. Okay, now it is for hollow cylinder. Hollow cylinder. Hollow cylinder. Now for hollow cylinder, what will be the moment of inertia? So if I take a ring, and if I extend it, it will become a hollow cylinder. That means based on for the x-axis, Now this is y, x and z axis. So it will be half mr square, mr square, full mr square, okay. And for this for not x axis, this for z axis. Z axis will be full mr square, and for that one I also forgot, because we don't use hollow cylinder normally most of the time. We do not use hollow cylinder. Okay, so I will look from my book and I'll tell you. So it will be, I was correct. So ml square by 12 plus mr square by 2. It will be for hollow cylinder. Now it is for rod. Rod means now along the y-axis, y-axis x-axis, z-axis. Okay, so for x-axis and z-axis, it will be ml square by 12. Now, I think for moment of inertia for rod at that moment will be 0, I think. I don't know. I'll check now. Okay, 0. There will be 0 because this is passing through the diametrical axis, so it will be 0 anyways. Because here no, there is no space. It's a very thin rod. Understand? So only these two will be calculated and this will be hollow. So please note this down, these three. Or I'll write one more down. Next is sphere. Next one is sphere. So now sphere x, y, z. I mean y, x, z. Okay. Anyway, it is spinning. Anyway, if I spin, it will be 2 by 5 mr square, 2 by 5 mr square, 2 by 5 mr square, because all three will be same. Because it is moving in any direction you move, it will be 2 by 5 mr square. Okay, now this one I think, I hope you noted down. Please. Yeah, now. So all done, this done, that done, this done. Okay, yeah, now it is spherical shell. Now what is it? It is a spherical shell. For rod, one more case is there. Example, now one rod is like this. At this point, what will be the moment of inertia? That will be ml square by 3, where L is the length of the rod. Okay, where L is the length of the rod. Now, next one is for hollow sphere. In many books they will be given spherical shell, but I am making it easier and calling it hollow sphere. That means 1, 2, 3. That means hollow sphere will be obviously, okay, this is y, x, z. That means it will be 2x, 2 by 3 mr square, 2 by 3 mr square, and 2 by 3 mr square. Very simple, no need to take tension. And last one, or I think second last one, I don't know. I erased this on accident. No shit. Okay. Now, hollow triangle. Triangle. What is the okay? So that means now this is a triangle. Okay. So I have written three cases because triangle we do not use mostly. Okay. So triangle is a triangle. The triangle of height h and base b. Okay. So now this one you note it down. Height is h. Height is h for triangle. Base is b. Mass is m. Yeah. So now for a triangle which is about the base, meaning the axis is like this. Axis is like this means it will be mh square by 6. Okay. Next one, it is perpendicular to the base. Exactly perpendicular to the base. Perpendicular. That means perpendicular to the base means like this. That means it will be mb square by 24. Okay. Now next is, now if it's like this, if it is on the z axis, that means it will be mh square by 18 plus mb square by 24. Okay, and last point in the triangle. That means, now example, this is the centroid G. You know what is a centroid? When all the three medians intersect. One median, one more median, one more median. So this is G centroid. That means one x is horizontally passing through this one. That means it will be mh square by 18 or 18. Last one is square. Last one is square. Side of the square is A. Okay, side of the square is A. This is from y, x, z axis. Side, that means here it will be ma square by 12 because side is the same. But for this one it will be ma square by 6. Okay, yeah. So now this is for all the shapes that I could find in my book, in the 11th book, and everything which I could find, and based on all the three axes. All three axes I have based. So yeah. So now all of this is correct. According to me, it is correct. Okay. So next video I will explain what is radius of gyration. Or this video itself, it's small topic. I think I can finish radius of gyration. And next topic I can start, or I'll finish both the topics now because already enough time is 6 minutes I have. Okay, yeah. Okay. Now radius of gyration K. Radius of gyration K. K. What is K? Okay, fine. I will explain. Okay. So now we already learned that I is equal to m k square. Now we already learned this. I is equal to mr square, where k is the perpendicular distance from the axis. We learned this. Now k, if I just find, this is radius of gyration. Simple. Now, what is the radius of gyration of a sphere moving on z-axis? Now, sphere on any axis, it will be 2 by 5 mr square. So now I'll find the r value. Now I'll find the radius of gyration. That means the mass, the root of this one. That means 2 by 5 root r. This will be the radius of gyration of a sphere. What about for a rod or a cylinder which is moving in the x-axis? Cylinder in the x-axis, that will be ml square by 12 plus mr square by 4. That means now I will divide this by mass and whole root it. That means I'll get root of L square by 12 plus R square by 4. So this will be the radius of gyration of this both. So this is how you have to find radius of gyration. So this is a very simple topic, radius of gyration. Next one we are going to learn is two theorems. Perpendicular axis and parallel axis. Perpendicular axis and parallel axis. So these are the two things which I am going to learn. Now perpendicular axis means, example, this is some value, radius r. Radius is r. Okay, radius is r means this will fall down. Fall down means the distance will be x and this distance will be y. Right? Yeah. Now I will say that the ix value means which will be distance towards the x-axis from the point. Distance towards the x-axis perpendicular towards the point. That means ix is equal to my square, because this is perpendicular to the x-axis and this is the inertia point. Okay, if it's rotating, then iy is equal to mx square. Very good. Now if I want to find iz square, that means it is r square. So I can write this according now these are the three things. Perpendicular axis theory says that if I equate the sum of ix plus iy is equal to z, then I can also get radius kx square plus ky square is equal to kz square. So this is for moment of inertia and radius of gyration. Moment of inertia and radius of gyration. Okay. So now these both are the values. For moment of inertia and radius of gyration. The parallel axis. Perpendicular axis theory says, example, my axis is here on the center, and I want to shift my axis here parallel towards the first axis. So parallel axis theorem says, if the length is d, that means and the moment of inertia here is ic in the center of mass. That means ic plus md square is equal to the inertia here. So inertia here plus the inertia between the distance crossed is equal to the inertia here. So I is equal to ic plus md square. This is parallel axis theorem. Or with this is for moment of inertia. For radius of gyration, k square is equal to kc square plus d square. This is for radius of gyration. So these two are the very important theorems you have to keep in mind, so whenever you are solving a question. Okay, so I hope you understood these concepts. This is very, very important. Okay, please note this down right now. 1, 2, 3, 4, 5. Okay, so thank you students for listening this lecture. I hope you enjoyed it. Please like, share and subscribe. My name is Arnav Satya. Meet in the next channel. Bye. Next video, not channel. Video. Bye bye. Tata.